Okay, let me solve some problems and show you how can we use the algorithm for the multiple roots. As the first example number 1, let me write the problem. Consider the equation. Consider the equation f of x equal to cosine of x times 1 minus sine of x. Okay, now part 1, show that x equal to p over 2 is a root of multiplicity 3 Let me solve part by part. For the solution, we should show that f of p over 2 is equal to 0, f prime of p over 2 is 0, and f double prime is 0, and f triple prime is not 0. Okay, so let me consider f of x equal to cosine of x minus half sine of 2x, something like this, sine of 2x. Then f of p over 2 will be cosine of p half is 1 minus 1, and it's equal to 0. Now let me compute cosine f prime of x is minus sine of x minus cosine of x, and this gives cosine of 2x. Okay, and this gives f prime of p over 2 is minus 1 plus 1, and it will be 0. Now let me show you f double prime of x. It will be minus cosine of x plus 2 sine of 2x, and if we compute f double prime p over 2, it's 0 in fact, plus 0, and it will be 0. Okay, now finally let me compute f triple prime of x. It will be sine of x plus 4 cosine of x, and this gives p over 2 is 1 minus cosine to 2x 4, and it will be minus 3, and this is not equal to 0. So by these 3 parts and also this one I get x equal to p over 2 is a root of multiplicity 3. This is the first part of the problem. But in the second part of the problem, I want to find the root. In the second part, I want to find root x equal to p over 2 by Newton method. In fact, we want to use the modified Newton method, and we know that the sequence should be xn plus 1 equal to xn minus f of xn times f prime of xn over f prime of xn squared minus f of xn times f double prime of xn. Okay, now let me show you the solution in the MATLAB program. Let me show the solution by Newton method. Let me comment this one and consider this one as the equation, and let me comment this part and this one as the y prime. Let me see what happened when we use the regular Newton method for this kind of the solutions. Okay, let me start by half, save program and run. Now, if you look at the iterations, you can see that in 33 iterations we get 1.57 and so on. And if you compute p over 2, it's exactly, in fact, it's the same as the p over 2. Look at the number of iteration, 33. Okay. In fact, the Newton method here doesn't work, doesn't converge quadratically. It converge maybe linear or underlinear. Okay. Now let me use the new algorithm and let me consider this one as yp and comment this one y prime of p minus, no, this is not correct. My equation is this one, cosine of x minus half sine of x. So I should change. Let me put cosine of x minus half times sine of 2x. So here the derivative should be minus sine of x minus cosine of 2x and no. Yeah, it was correct. I should start from here. I was wrong. This is the equation, cosine of x minus half sine of 2x. And this is the derivative, first derivative in fact. And this is the second derivative, minus cosine of x plus 2 sine of x. And let me start with half and run the program. And you can see that just in 4 iterations we get the correct solution, p over 2, 1.7, and it works. Okay, so if you want to find the root of a nonlinear equation with the multiplicity of more than 1, you can use this algorithm and find their roots very, very fast. Now, let me solve 2 more problems about the order of convergence. The first one, let me write the problem first. Example number 2. Consider the sequence xn, n equal to 0 to infinity, defined by xn plus 1 equal to xn squared plus 1 over 2xn for n equal to 0, 1, 2, and so on. The first part of the equation show that for all x0 greater than 0 and close to 1, the sequence converges to 1. Okay, it's very simple. If we want to solve this kind of problem, you should just let limit of xn, n goes to infinity, n goes to infinity, be equal to x. Okay, then take limit both sides. Xn squared plus 1 over 2 xn, n goes to infinity, and this gives the left part, the left hand side here, it should be 1. Okay, and if I consider limit of xn in the denominator, it will be x, and in the denominator also this one should be x. So finally we get x equal to x squared plus 1 over 2x, and this gives an equation that we should solve. It should be 2x to power of 2x squared equal to x squared plus 1. In fact, this gives 2x squared equal to x squared plus 1, and this gives x squared equal to 1, and this gives x equal to 1. In fact, it's positive and negative 1, but in fact minus and plus 1, but the minus is not acceptable, and just x equal to 1 is the solution. But the second part is a little tricky, and you should know something. In fact, the second part is that find the order of convergence. Of xn for n equal to 0 to infinity. In fact, we want to find the order of convergence for the sequence. For solve some problems, you have to construct this item. In fact, you have to construct something like this: en over en squared in absolute value equal to lambda when n goes to infinity. We have to construct this one. Yeah, this one. To this end, we have to do something. Let en equal to xn minus 1. We have to consider the root of the equation here, or the limit of the sequence here, xn minus 1. Okay, and we try to construct this limit. We start from xn plus 1 equal to xn squared plus 1 over 2xn. We subtract minus 1 from both sides. So we get xn plus 1 minus 1 equal to xn squared plus 1 over 2xn minus 1. And this will be xn squared plus 1 minus 2xn over 2xn, and it will be xn minus 1 squared over 2xn. So what we get? In fact, we get xn minus 1, xn plus 1 minus 1 equal to xn minus 1 squared over 2xn. Okay, now you consider this one as in en plus 1 and this one as en. So we get en plus 1 equal to en squared over 2xn, and this gives absolute value of en plus 1 over en squared equal to 1 over 2xn. Okay, now take limit from both sides. So we get limit absolute value en plus 1 over absolute value en squared equal to limit 1 over 2xn, and n goes to infinity. We know that this limit is equal to 1, so it will be 1 over 2. So what we get? We get limit absolute value of en plus 1 over en squared equal to half when n goes to infinity. Now we can consider this one as alpha and this one as lambda. Okay, so the rate of convergence is alpha equal to 2, and we can say that this sequence converge to 1 quadratically. Okay, this is in fact the solution of the problem. Now let me solve another problem. Example number 3. Consider the sequence xn n equal to 0 to infinity defined by like this: xn plus 1 equal to xn times xn squared plus 3r over 3xn squared plus r for r greater than 0 and n equal to 0, 1, 2 and so on. Okay, what we want to find in fact the number that the sequence converge to that number, and also we want to find the order of convergence. So the first part, find the number that xn for n equal to 0 infinity converges to that number. This is the first part. Let me solve the first part first and then the other one. To this end, we again consider and let in fact n goes to infinity. xn is equal to, for example, something x. Okay, so if we take the limit from both sides, we can get limit xn plus 1 n goes to infinity equal to limit n goes to infinity xn power of 3 plus 3r xn over 3xn squared plus r. Okay, now here we can get this one should be x, and here we have 1x power of 3 here, is 3rx here and 3x squared plus r here. If we multiply both sides in the denominator of the right hand side, we get 3x3 plus rx equal to x3 plus 3rx, and this gives 2x3 minus 2rx equal to 0, and this gives 2x times x squared minus r equal to 0, and this gives x equal to 0. It's not acceptable, okay? And the other one, x squared equal to r, and this gives x equal to minus the square root of r, not acceptable, and x is equal to square root of r, and this is okay and acceptable. Okay, now this is the first part. And about the second part, find the order of convergence. To this end, we in fact should construct again this limit. Limit absolute value en plus 1 over absolute value en squared equal to lambda when n goes to infinity. Okay, let xn minus square root of r be n. Okay, and now add in fact subtract minus r from both sides of the sequence, so we get xn plus 1 minus square root of r equal to, here look here, xn to power of 3 plus 3r xn over this one. So let me write it, xn to power of 3 minus 3r xn over 3xn squared, plus r, and this should be plus r minus square root of r. Okay, we simplify the right hand side, we get xn squared plus 3r xn minus 3 square root of r xn square plus r square root, and it should be minus, not plus, okay, over 3xn squared plus r. Now here, if you consider this one, this will be xn minus square root of r to power of 3. Okay, and this one should be en plus 1, and this one is en. So we get something like this. En plus 1 equal to en squared over 3xn squared plus r. Okay, take absolute value, both sides, en cube 3xn squared plus r, and divide both sides by absolute value of en, so we get en plus 1 absolute value over absolute value of en cube equal to 1 over 3xn squared plus r. Take limit absolute value en plus 1 over absolute value en cube, n goes to infinity, equal to limit (1 over 3xn squared plus r). We know that this limit should be r. Okay, xn goes to square root of r and xn squared go to r. Okay, so finally we get limit absolute value of en plus 1 over absolute value of en squared equal to 1 over 4r. Now you consider this one as alpha and this value as lambda. So it gives that order of convergence is alpha equal to 3. And what this says that this sequence goes to the square root of r of order number 3, and it will be very, very fast. Okay, so you saw some examples about the multiplicity of root and finding the order of the sequences, and I will continue with the finding the roots of the equations, in fact for the polynomials, and finding the root of the polynomials and Horner method in the next lecture. Please subscribe my channel and introduce my channel to your friends. Thank you.